Here's number 13 on 1.4. And what I want to start with is let's go ahead and eliminate our x's first. So on the second equation, I'm going to go ahead and multiply it by a negative. So that will become negative x minus y plus z equals 0. And then I'll take the second equation and I'll do x plus 3y minus z equals 2. So I add them together, the x's cancel. I have 2y equals 2. Divide by 2. So y equals 1. And let's continue to, let's get rid of our x's again. And I definitely need to use my third equation. And in order to get rid of that, let's multiply the first equation by a negative 3. So negative 3x minus 9y minus 3z equals negative 6. And I apologize, that should be a positive 3z. And then we'll take the equation below, equation 3, and add it together. 3x plus 2y minus 3z equals negative 1. So my x's cancel, my z's cancel, and again I'm still getting my y value the same. So I get negative 7y equals negative 7, and I still get y equals 1. So what I may need to do is, well, that is it. Because I get y equals 1 for both, they're the same, that means I have infinitely many solutions. Infinitely many solutions. And so now we need to do that extra little step in order to write it as an ordered triple. So in order to do that, I am going to take one of my equations. Let's take the first equation here. And I'm going to write x plus 3y minus z equals 2. And I'm going to substitute my y value inside. And so I have x plus 3 times 1 minus z equals 2. So I get x plus 3 minus z equals 2. Subtract 3 from both sides. I get x minus z equals negative 1. So let's go ahead and solve it in terms of x. So what that means is I'm going to have to isolate my x value. I add z to both sides. And so I get x equals z minus 1. And now because I already have a z value here, a z, I'm going to keep it the same. So the x, remember this is x, y, z is your ordered triple. X equals z minus 1. My y value, I have that up here at the top. So y equals 1. And then it's in terms of x, and x equals z minus 1. And so let's just make this z. So that way we only have one variable that we're looking at. And so this is the answer that you would plug in to Big Ideas, and that would be correct.